Welcome to this video on linear algebra for GATE DA. We will be discussing the linear dependence and independence of vectors. First, let's review the background. A linear combination of vectors v1 through vn means we can express it as a sum of these vectors, each multiplied by a scalar, such as a 1 through n. Vectors are linearly dependent if the equation a1v1 plus anvn equals 0 has a solution where at least one coefficient is non-zero. Linear dependence means one vector can be written as a combination of the others. For example, if v3 equals 2v1 minus v2, we have non-zero coefficients in the linear combination equaling 0. Consider the 2D example with vector v1 equals 1, 2, and v2 equals 2, 4. Since v2 equals 2v1, the relationship 2v1 minus v2 equals 0 has a non-trivial solution, indicating linear dependence. Vectors are linearly independent if the equation a1v1 plus anvn equals 0 has only the trivial solution where all scalars, a 1 through n, are 0. The meaning of linear independence is that no vector can be written using the others. Each vector adds a new direction to the set. For an example of linear independent vectors, consider v1 equals 1, 0, and v2 equals 0, 1. The equation a1v1 plus a2v2 equals 0, 0 only holds if a 1 and a 2 are 0, the trivial solution. To test for linear dependence, you can use the matrix test. If you put the vectors as columns in matrix A, they are dependent if the determinant of A equals 0 and independent if it is non-zero. Another method is the rank test. The vectors are linearly independent if the rank of matrix A equals the number of vectors and dependent otherwise. Important properties include having more vectors than the dimension, such as 3 vectors in R squared, always leads to dependence. Also, if a 0 vector is present, the set is always dependent. Geometrically, in 2D, independent vectors make a plane, while dependent vectors lie on the same line. In 3D, independent vectors fill space, and dependent ones lie on a plane or line. Some fast checks. Parallel vectors are dependent, orthogonal vectors are independent. In data science, PCA removes dependent features and redundancy, while correlated features relate to dependence in deep learning. Thank you for watching this video.